Half-lives are a mathematical concept that describe how many things decay. Any unstable atoms or quantum particles will decay and turn into more stable particles that have lower masses. The fact that the decay products have a lower mass than the original particle means that energy must be produced to make up for the lost mass. As a result, this reaction doesn't need any energy to occur. It produces energy. This means that it can occur whenever it wants. So, how does an unstable particle decide when to decay? No unstable particle has a set time that it will last. Since the reaction can occur whenever it wants, there is a randomness to how long the particles will last. We can determine a point in time where there is a 50-50 chance as to whether the reaction occurred before or after it. This point is a particle's half-life, and different particles have different half-lives based on how unstable they are. The more unstable a particle, the more energy released when the particle decays, and the shorter the half-life will be. It makes sense intuitively. More unstable things will break apart faster. A property about half-lives is that each half-life that passes decreases the chance of an unstable particle remaining by half. By the first half-life, there is a 50% chance that the particle hasn't decayed. By the second, there is a 25% chance that the particle hasn't decayed. By the third, there is a 12.5% chance that it hasn't decayed, and so on. Each successive half-life, the particle basically pretends like the last one didn't happen, so each half-life that passes, there is a 50% chance of the particle decaying. Practically, we never experience just one of a particle in our macroscopic world. We see materials that are made of many particles. Here, the rules manifest in a slightly different way. After the first half-life, half of the material has decayed, and half remains. After the second half-life, half of the remaining half of particles has decayed. In other words, only 1/4 of the original substance is left. This continues in the same pattern with the amount of original material halving each time. When a particle decays, it can release dangerous materials such as alpha particles, beta particles, and gamma rays. This is the dangerous stuff in radioactivity. The shorter a particle's half-life, the quicker it will release this radiation. As a result, substances that are considered very radioactive are the ones with the shortest half-lives. Half-lives are a very simple mathematical concept, but their properties are fairly interesting. The way that half-lives invoke randomness in the quantum world allow them to be used in random number generation and other situations. Understanding them is an important skill to have.